Okay, so I'm going to try really hard to make this the last video, right, because we still have some other files to do. Again, really, you have to have a good understanding of things before you even attempt to build on trigonometry, as you will see. So how do we solve equations? Well, as you've seen in some previous examples, the golden rule is whatever you do to one side of the equation, if you add, you have to add to the other. If you subtract, you have to subtract. If you divide, you have to divide. If you multiply, you have to multiply. You square, you have to square. So that's basically the golden rule. But what also comes into play is what kind of equation are we looking at, right? So this first one is a linear equation. This next one is a quadratic. And this next one's a rational. So what we do to solve these changes as we use that golden rule. So lines are pretty simple, right? We basically simplify and then start moving some stuff around. So I'll begin this journey by distributing on that side. I can't really do anything with 5x minus 6. I think I distributed right. Combining like terms, we get 2x minus 10 equals 5x minus 6. And now I can start playing my golden rule game. It looks like I can probably be subtracting 2x from both sides and maybe adding 6 to both sides. That gives us negative 4 equals 3x. Divide both sides by 3, and we get the solution as x equals negative 4/3. Of course, what we could do to verify that that's true is plug it in and see that one side is actually equal to the other, but I'm not going to do that here because we're just concentrating on solving. Quadratics. Now to solve a quadratic, one way that you've seen so far is to factor. So what I first would have to do is subtract that 4 over and get that factored. Of course, if it doesn't factor, we can use the quadratic formula. You can use the square root property. There's all kinds of stuff to do that, but I think this factors. So let me just, I'm a guesser and a checker. I think that is going to get the job done, right? So first times first is first, last times last is last. The outer is a negative 8x, the inner is a positive x. Oops, so that's not going to work there. So let's see. Yeah, as a matter of fact, I don't think it factors. So since it doesn't factor, we're going to use the quadratic formula. So a is 2, b is negative 1, and c is negative 4. So negative 1 plus or minus negative 1 squared minus a 4 times an a times a c, all over 2 times a. So x, we get a 1 plus or minus 1. Let's see, 4 times 2 is 8 times a negative 4 is, so we'll get plus 32 all over 4. And so x equals 1 plus or minus the square root of 33 over 4. And not a very nice, neat number. I think we kind of anticipated it since that didn't factor. Okay, to solve a rational function, an equation, what we typically do is try to clear out the denominator. So in this case, we find the LCD, and one of my denominators is x plus 2, the other is x minus 4, so my LCD is that. And so what we typically do is multiply both sides by that LCD. And over here, the x minus 4's cancel out, leaving us with 2 times x plus 2. Over here, the x plus 2's cancel out, leaving us with 3 times x minus 4, right? Which kind of basically proves the good old cross multiplication idea, all right? So you either see it as clearing the fractions by multiplying both sides by LCD, or since we were dealing with proportion, we could have cross multiplied and made our lives a little simpler, but either way. And so now we basically have a line to solve. So distributing on both sides. I think I distributed right. I can subtract 2x and add 12, and it looks like we get x equals 16 as our solution. All right, so hopefully that's some decent review on solving lines, quadratics, and rational equations, which happen to be proportions. And again, we will see a lot of this in our course at some point or another. And I also think this is an appendix. I think it's what, B or something like that, or even A, I think, appendix A. All right, so to get some more review. Another thing that is actually not in any appendices, so you'll probably have to do a Google search if what I show you is not enough, is this concept of solving a system of equations. There's a lot of different ways to do it, and unfortunately, right, if you're not linear, the only thing that works is substitution. So I'm going to show you a substitution technique, and we'll go from there. So to do a substitution technique, I basically have to substitute a value for one variable into the other equation. So looking at these three, B's ready to go, right? Because here's what y is, so I'm going to substitute it for y in the other equation. So that gives us x plus x squared plus x equals 8. And then this is x squared plus 2x equals 8. So by making that substitution, by substituting one equation to the other, we end up with a quadratic to solve. And so this basically gives us x squared plus 2x minus 8. I believe this one will factor. All right, and so we get -4 and +2. However, since it's talking about a system, we're looking for an ordered pair, right, an x and y that satisfies both. I only have the x coordinate for that information. So when x is -4, it doesn't matter which one you use. How about I use this one, right? When x is -4, it looks like the y value will be 12. So one of our solution points to this system is -4, 12. When x is 2, we get 6. So 2 and 6 would be the other. So there's two solution points. If we were to graph this line and we were to graph this parabola, right, they would be crossing at those two junctures. And that's pretty much what it means. Oops, I think I missed you guys there at the end. Sorry about that. That's pretty much what it means to solve a system of equations. We usually have an ordered pair. The next two aren't so simple. In this case, let me try the harder one, right? Neither one is solved for y and x, but this guy, if we multiply both sides by x, right, what we get is y equals 10x. So I can now substitute over here. So we get 10x over x plus 4 equals 3. So we can multiply both sides by the LCD, and we get 10x, this cancels out, equals 3x plus 4. So this gives us 10x equals 3x plus 12. If I subtract 3x from both sides, we basically get that 7x is equal to 12, divide by 7. We get x equals 12 over 7. Of course, we still need to go find y, so how about we just use that? Since y is 10x, this means y is 10 times 12 over 7, so y is 120 over 7. So the ordered pair that solves this is 12 over 7 and 120 over 7, right? So a little bit harder to do, but the same idea of substitution. Last but not least, this is a linear one, so some of you might want to use some other technique, but let's stick with substitution. And how about I subtract 2x from both sides, and we get y basically equals 5 minus 2x. I can now substitute it for y there. So we get x minus 3, 5 minus 2x equals, equals -1. And so this is x minus 15 plus 6x equals -1, which is 7x minus 15 equals -1. If we add 15 to both sides, we get 7x equals 14. Divide by 7, we get x equals 2. That's just the x coordinate. What about the y coordinate? Well, that'd be 5 and 2 minus 2, which is 5 minus 4, y equals 1. So the ordered pair that solves that system would be 2, 1. And that's basically how you solve a system. Again, being able to solve a system will be important when we're solving some of our situations that deal with right triangles and whatnot and trigonometric functions, and we'll commonly be using substitution. So make sure you understand that, Google it and review it, because I do believe that the book doesn't have any on that. So there's a very thorough review of your function material, right? We got some more, we got some abstract ideas and some right triangles to work on, but we'll obviously use some other videos for that. See you guys then.